What's going on, everybody? Welcome. And today, I want to talk about something really cool and interesting that happened a few days ago. It's been in the works for for I think some months or years now. We now have, we as in people of the planet Earth, we now have the first actual image of a black hole. Now, people probably say, well, we already had images. No, let me explain. All of the images, we'll play this. You take all of the math and science that goes into astrophysics with I think it was using Einstein's general theory of relativity, and all that we know about the math, we have comprised images of black holes and what they will look like. Right? We know what a black hole is. It's the core of a dying star that collapses in on itself. Well, if I break that down, when a star gets to a certain size and it's reached its, I guess, last breaths, so to speak, the star explodes into a supernova. A supernova is a dead star. It's an explosion of a dead star. At times, what's left is the core of the star. The core of the star is what's left. That thing is called a neutron star. Okay, it's extremely dense, right? It's the core. Now, what happens is when the core of the star reaches a certain density, right? It can't hold it, and it collapses in on itself. Okay, the core of the star collapses in on itself to a point where it creates what's called a black hole with a density so powerful, with mass. I say with a mass so powerful that light can't escape it. Okay, it's a black hole. Now, we know what a black hole is, and we know what a black hole should look like. However, based off what we know already from Einstein's formulas and all that, we've been showing images of what it would look like if we actually found an image of a black hole. Well, we finally have one for the first time. We finally have an actual image of a black hole. Okay, and what's great about it is the image that we have of the actual black hole is exactly how we predicted it would be, how Einstein's theories predicted it would be. Everything that Einstein said that you will see in a black hole, or around a black hole, I should say, was accurate and correct. So that's really what is the shocker, that we actually found the image of a black hole, and everything that we said it was going to be, it is. And if you look at the image, I don't have the image on me, but if you look at the image, look at the actual image, you'll see a black circle. Even though the circle looks very small, I promise you, it is not small. And I think this particular black hole is about, what, 55 million light years away, which is amazing because a light year is the distance that light travels in 1 year, which is estimated 6 trillion miles. Okay, and that the light from that image takes 55 million years to reach us. That's how that works. So the light from that black hole has finally reached us 55 million years later, and the image that is shown is the one you see on social media. Just go on social media, type in black hole, you'll see. And the thing is, it wasn't just one telescope. There were a bunch of different telescopes around the world. So this is a worldwide thing. This is a worldwide event. Oh, Lord. It's a worldwide thing. So a bunch of telescopes around the world gathered all the information, all their data together, and we have the first real image. It's not a fake image. It's a real image of a black hole. Okay, it's a real image of a black hole, and if you look at the image of the black hole, you'll see, like I said, you'll see a small circle. You'll see a black circle. That's the black hole itself, and then you'll see just like a ring of light around it. Okay. What's also astonishing about the black hole is a black hole has so much mass and is so dense. It curves space to the point where light gets distorted. Light actually bends at almost a 90-degree angle. Now, here's the thing. Mass curves space. Anything that has mass distorts space in some form or fashion. We have mass. We actually distort space. It's very small for us. Like, it's not like something like the sun or anything like that. Our sun distorts space. We distort space. Earth distorts space. So the greater the mass, the greater the distortion, especially of light. So when a black hole is present, everything gets distorted so severely. It almost, it's like how, what's it called, the funhouse mirrors, how you go into the mirror and everything looks warped and distorted. That's what happens when a black hole is present. Space-time gets distorted, light gets distorted, gravity gets distorted, everything gets distorted. So the light that you see around the black hole is not coming out of the black hole. No, because light can't escape out of a black hole. But the light that you see from the black hole is the light from other stars behind the black hole, that in the presence of the gravity of the black hole gets distorted so severely that it's like at a 90-degree angle. That tells you how great the mass of a black hole is. And then the mass the smallest amount of space you can have. That great, like imagine the Earth. Imagine the Earth being squeezed down all the way to the size of a pea. I don't know, like something like that. So imagine a star. Imagine a star, a big star, pushed all the way down to the size of your car. The mass hasn't changed. The size changed because And because the size has the space has changed, it's greater. So we now have an actual image of a black hole. That's probably one of the most powerful images we have ever had since landing on the moon and seeing Earth. That's how significant that is. Imagine the first time we saw Earth, the actual Earth, not the image, but the actual Earth. That's how it is when we actually see the first image of a black hole. I just want y'all to pay attention to the significance of that. All right, we Earth did it. Found a black hole. Actually, no, it was two. It was two astrophysicists. It was two women that found it. Two. I forgot their names. Pardon me, but two women that found it. So great day in history. Catch y'all later. Peace.